So hello everyone, welcome back to this lecture series on the topics of numerical methods. So in the previous lecture, we discussed about interpolation and the Newton forward interpolation formula, okay, which is basically based on the construction of interpolating polynomial for given observation or data set. Okay. Now in this lecture, I am going to discuss about Newton backward interpolation formula. Okay. So let us start with introduction of interpolation. Okay. So suppose if we have some observation or data set like which are given in this table. So in this table we have n plus 1 data points and their function values. Okay. So if we have some data points, so with the help of these data points we can construct a polynomial which fit all the data points exactly. Okay, and that polynomial is called the interpolating polynomial. Okay. Now what is Newton backward interpolation method? So Newton backward interpolation method is one of the most important interpolating technique which is used to find the approximate function fx. Okay, and it is especially useful when the data points are equally spaced. Equally spaced means the distance between each data points are equal. Means xi, we can write in general xi equal to x naught plus ih, where I is vary from 1 to n. Okay, or we can say this is distance from x1 minus x naught is given h, x2 minus x1 is given h. Okay, similarly xn minus 1 is also given h. Okay, so distance between any two consecutive data are equal. Okay, and this method is used to estimate the value between the known data points. Means this method is useful to calculate the value of unknown lies between x0 to xn. Okay, so with the help of interpolating polynomial you can calculate any value between lies between x0 to xn. Okay, so now I am going to write the Newton backward interpolating formula directly. Okay, because I will not give you the whole proof here because it will take so much time. So if we have n plus 1 data points, so we can write a function fx, okay, equal to f of xn plus p delta f of xn plus p plus 1 divided by factorial 2 del 2 f of xn plus dot p plus 1 p plus 2 p plus n minus 1 divided by factorial n and del n f of xn. Okay, and what is p here? So like Newton forward interpolation formula, p is here similar to the Newton forward interpolating polynomial is x minus, in place of x naught here we will use xn, okay, divided by h. So if you compare this formula to the Newton forward interpolation formula, then you will see here xn is used. Okay, in each term you can see here xn is used. So the point is, in case of Newton forward interpolation we will use initial point of the table, okay, means x naught, and in the Newton backward interpolation we will use the last point of the given table. okay, means xn. So remember this point, okay. And what is this del f of xn? This is your first backward difference, okay. This is your second backward difference. Similarly, this is your nth backward difference, okay. So you can calculate these things using the backward difference table, okay. And what is h here? H is always let us write what is h here. H is again step size, and xn is basically tabular value, okay. Okay, means for each n we will have a tabular value, okay. Now let us consider one example. So suppose if we have some data set like here it is given the value of x is given 4, 6, 8, 10 and the function is given 1, 3, 8 and 20, okay. And we have to calculate the approximate value of function at point x equal to 9, okay. So we have to calculate value at 9. So first what we will do, we will calculate the interpolating polynomial, okay, or interpolating function. And if we have interpolating function, we can put the value 9 in place of x, then you will get the function value, okay. So to calculate the interpolating polynomial, we have to calculate the backward difference table, okay. Del f of xn, del 2 f of xn and del f of xn, okay. So first we will write this table into the form of column, like this is your x and this one is fx, okay. So your x is given 4, 6, 8 and 10. So basically this one is x0, this one is x1, this one is x2, this one is x3. Since we have only 4 data points, so up to x3 we have, okay. And the function value is given 1, 3, 8 and 20, okay. Sorry. So if we have x and fx, we can calculate the first backward difference, means this delta f of x, okay. And how to calculate? So if you use the backward difference at this point x0, okay, you cannot use the backward difference at this point, okay, at this point x0, because in backward difference the previous point is required, okay. So we can use the backward difference at this point, okay, means at x1. So the first backward difference delta f of x1 is given f of x1 minus f of x0. So f of x1 is 3 minus 1, okay. So this is 2. Similarly, the first forward difference at f of x2, this is 8 minus 3, so 5, and delta f of x3 is given 20 minus 8 is 12, okay. This is your first backward difference. Similarly, if we have first backward difference, we can calculate del 2 f of x, second backward difference, okay. So again, what will be the del 2 f of x2, okay, because we cannot calculate del 2 f of x1 because we don't have previous point at this before x1, okay. So we will calculate del 2 f of x2. So what is del 2 f of x2? Del 2 f of x2 means del f of x2 minus del f of x1, okay. So this is 5 minus 2 is 3. Similarly, we can calculate del 2 f of x3. So del 2 f of x3 means del f of x3 minus del f of x2. So it is 12 minus 5 equal to 7, okay. Now we can calculate del cube f of x. So del cube f of x3, okay, equal to del cube f of x3 minus del square f of x3 minus del square f of x2. So this 7 minus 3 equal to 4. Okay. So now we can use here. Now we can use the interpolating formula. Since we have del cube f of x3, del square f of x3, del f of x3 and f of x3. Okay. So now we can use the Newton backward interpolation formula. So what is the formula here? So fx equal to f of xn plus p del f of xn plus p plus 1 divided by factorial 2 del 2 f of xn plus p plus 1 p plus 2 divided by factorial 3 del cube f of xn. Okay, so up to del cube you have to write here. Okay, because here del 4 f of x is 0. Okay, so up to delta cube you have to calculate only. Now what is p? P is given x minus xn divided by h. Okay, so what is h here? H is distance between two data points. So distance between these two data points are given 2. Okay, so h is given 2. What is xn? Xn is the last value of your table. Okay, so your table last value is 10. Okay, so here it is 10. And we want to find the value of 9. Okay, means function value at 9, means your x value is given 9. So if you have x, h and xn, you can calculate p. What is p here? P equal to 9 minus 10 divided by 2. Okay, so it is minus 1 divided by 2, it is minus 0.5. Okay, so you can substitute all these values in this function. Okay, so you will get fx. So f of 9 equal to f of 10 plus, what is p here? P is minus 0.5. Okay, so minus 0.5 into, what is the first backward difference? It is 12. Okay, it is into 12 plus p plus 1. P means minus 0.5 into minus 0.5 plus 1 divided by factorial 2, and del 2 f of xn means del 2 f of x3. Okay, it is equal to 7 plus this is minus 0.5 minus 0.5 plus 1 minus 0.5 plus 2 divided by factorial 3, and del cube f of xn means del cube f of x3. Okay, so this is your into 4. Now what is f10? F10 is given 20. It is 20. Okay, and if you multiply 12 by minus 0.16, you will get minus 6. Okay, so this is minus 6. Again, if you solve this quantity, then you will get minus 0.875 and minus, if you solve this one, you will get 0.25. Okay. And if you add all these, then you will get 12.875. So this is the value of F9. Similarly, you can calculate any value lies between 4 and 10. Okay. So this is your example 2. Okay. So you can try this example yourself. And here you can see you have total 1, 2, 3, 4, 5 data points, and using Newton backward interpolation formula, you have to estimate the battery voltage at t equal to 3.0 hours. Okay. So it is lies somewhere here, means 3.8. Okay. So you can use Newton backward interpolation formula here. So this is all about Newton backward interpolation formula. So if you have any doubt, then you are free to write in the comment box. And thank you everyone for watching this video. Thank you.